Alright, to use the AC method to vector this quadratic, what we first do, the first step, is to multiply the lead coefficient and the constant coefficient. In this case, that is 3 times 8 to get 24. Okay, so this is a number we're going to work with. What we need to find now are a pair of numbers that multiply to be 24, just like 3 times 8, but also add to be this 14 and the 14x right here. To do that, what I do is I'll create a factor tree for the numbers. So over 24, all the pairs of numbers that multiply to be 24, I'll write those out here. So here's all the possible pairings of numbers that multiply to be 24. I'm looking for the group that adds to be 14, and that is the 2 and the 12 right here. What I do with that information is I set up a factor by grouping question. So what I'm going to do is I'm going to take that middle term of 14x and I'm going to split it using the 2 and the 12. In this case, what I'll do is write that as 2x plus 12x plus 8. And again, this 2x plus 12x is just a representation of this 14x. In some ways of thinking of this, you're unsimplifying the 14x. Now all I need to do is factor by grouping with the polynomial I have set up here. So factor the greatest common factor out of this first set, which would just be an x, and leave me with a 3x plus 2. In the second group here, I would factor out a 4, and I'd get 3x plus 2. As always with factor by grouping, it's essential that this binomial factor is the same. If it is, what I do is factor that out of each. So I write 3x plus 2. I factor that out, and when I do that, what I'm left with is the x plus 4. That is this quadratic completely factored.